Hi everybody, today's lecture is about powders and granules. This lecture is based on a reference from Ansel's Pharmaceutical Dosage Forms and Drug Delivery System, 11th edition, chapter 6. After this lecture, students should be able to differentiate a powder from a granule, define pharmaceutical powders and their advantages, disadvantages, list design properties of pharmaceutical powders, explain how a drug's powder particle size influences the pharmaceutical dosage forms that will be used to administer it, define levitation, spatulation, titration, and geometric dilution, describe special considerations of powders, compare and contrast the various types of medicated powders as dosage forms, provide examples of medicated powders, describe granules and their applications, describe effervescent granules and give examples. In order to facilitate for viewing the big pictures and detail in this lecture, please check out the lecture outline here. First, we will learn about pharmaceutical powders, then design property of powders. Then we will learn about physical-chemical considerations of powders. Under this physical-chemical consideration, we will have subtopics of particle characteristic, particle size and analysis, and comminution of drugs. The big topic we learn is about blending and mixing of powders. Under blending and mixing, it can be manually or mechanical methods. For special considerations of powders, there's some special type of powders we will learn is about eutectics, hygroscopic and deliquescent powders, efflorescent powders, and how to incorporate powders into liquids. The next topic is about powders as dosage forms. A powder can be in dosage forms of topical powders, insufflatic powders, aerosol powders. Then we have some example for oral inhalation powders from aerosol powder, bulk powders, divided powders. The big topics next is to granules. Powder is one of the primary ingredients to make other dosage forms, or it can also be used as a medicated powders. That means it's used directly as a medicine. Pharmaceutical powders are intimate mixtures of dry, finely divided drugs and or chemicals that may be intended for internal or external use, for local or systemic effect. Powders can be in final dosage form or ingredients for other dosage forms in case powder is ingredients to make tablets, capsules, suspensions, solution, etc. Advantages of pharmaceutical powder is the flexibility of compounding. So powder can be easily be weighed or measured. Powder is a case has a good chemical stability because it's in solid dosage form. Mostly has no water, so the stability can be long. If we have the small particle size of powder is very good for rapid dispersion in case you use a powder to make a suspension. A disadvantage of powder is that if you use medicated powders, it's kinds of inaccuracy of dose, because usually the medicated powders, especially for the bulk powder, it can be measured using a scoop or some kind of spoon, so the accuracy of dose cannot be as compared as the capsules or tablets. Powders, even though in medicine or in ingredients for further dosage forms, need to have some desired properties. First of all, the powder needs to be fine and uniform in particle size. This one is very important for powders. The fine and uniform particle size have the mixture is consistent. If powder is used for topical application, The powder needs to be smooth to touch and non-irritating to the skin. The powder should be easily spread on the skin. So for topical application, usually the powder is made in the small size or fine size. For internal use, for example, for the oral, if powder used in the powder, if the powder is medicated for internal use, it can help to increase dissolution and bioavailability. So the property that need to help to increase the dissolution and bioavailability. For this purpose, the size is very important. The size should be like as fine as possible. If the powder is used as ingredients for other dosage forms, like in case the powder is made to make tablets and capsules later, the powder can affect the dissolution and bioavailability based on the size, as mentioned above. Usually, to have the fast dissolution rate, the micronized powder is usually used because it's in a fine powder, in a fine particle size. When the drug has a fast dissolution rate, it can increase the bioavailability of the drug. When the powder is used for ingredient for other dosage form, it also can affect the rate of settling. For example, in suspension, if the particle size is very large, the powder can settle down quickly and make the suspension less stable. Or for topical use, the large size can make like discomfort feeling for the patient. If the powder is used as bulk powders, it's important to avoid stratification of powder in transportation, because any stratification, it can make the inconsistency or ununiform of the powders among the bulky powders. So this one can, if any stratification, it can lead to the inaccurate dosing. So it's important for bulk powder in the transportation to avoid any stratification. It's important to understand about physical chemical properties of powders before making it a medicines or before making it a ingredients for tablets or capsules. There are three main items about physical chemical properties of powders. First is the particle size characteristics. Second, particle size and analysis. And the last one is a comminution of drugs. In particle size and characteristics, the particle size is important to be in a uniform size because uniformity will help the blending or mixing easier. If the size and particle size in different size, the blending and mixings will be difficult and can create a lot of junk. About particle shape, the spherical particles is more convenient for blending and mixing than the needle shape or cubic shape because these needle shape or cubic shape can be clogged together. So uniform size and spherical particle is important. About particle density, every drug or substance or particle has different density. If the density is heavy, then or have high density, the particle size had a tend to sink and less dense when you mix them together. If the particle density is small or is light, the particle size can rise and it's also difficult to mix them together. It's important if you have the similar density of the powder, it will be easy for blending and mixing. But in practice, when you have different compounds, you have different ingredients, the density can be different. So the mixing of the mixture of powders that have different density is more difficult. And it's important to know that when you mix with the lighter density, make sure that you put them like at the beginning so the dense density can mix with them and avoid any rising of the light. Electrostatic charge. Some ingredient or some powder particle can have the static electricity. If they have static electricity, that can hamper the blending. Some particle size of powders can have adhering or repelling properties. So mixing them together can be a challenge. For adhering or repelling powders, usually the particle or the powders will be diluted individually with inert substance first before mixing them together. Particle size is analyzed by many methods. One of the simple methods is using the sieving. The sieve has different size, and which each side has different pore size diameter here. The larger number of the sieve, the tighter of the pore size. This means the larger number will have more tight pore or smaller pore here. According to the USP, the powder size is categorized into 5 types. The first one is a very coarse powder. The sieve opening is 1,000 micrometer. So that means the average particle size can be around 1,000 micrometer or 1 milliliter. To determine this coarse size here, all particles must pass through sieve number 8 and not more than 20% of the powder pass through sieve number 60. When the size of the powder, average size of powder is smaller, it goes to the smallest size, and the category will be in the coarse size or number 20. The size opening or the sieve opening for this kind of particle is from 355 to 1,000 micrometer. So it's less than 1,000 micrometer. It's less than 1 millimeter. It's from 350 micrometer to 1 millimeter. The next category is moderately fine or number 40. So for this kind of particle of powder, the sieve opening is from 180 to 355 micrometer. The next level or categories of powders of particles is a fine, number 20. The sieve opening is from 125 to 180 micrometer. And the last one is a very fine powder, or number 80. The sieve opening to 90 to 125 micrometer. So in general, there are 5 types of size for powders, and it depends on the purpose of use. Different kinds of powder will be applied. The granules is kinds of agglomeratic of powders, and the size of granules usually larger than the size of the powder. It's ranging in 4 to 12 sieve size. In order to reduce particle size, there are many methods. And terminologies in reducing the particle size we call comminution. Comminution is grinding a drug in a mortar to reduce its particle size. There's many methods to do the comminution. Titration is usually applied in a small scale of preparation. Usually a mortar and pestle will be used. And with the force, the pestle will grind the particle in the mortar into small pieces. The next method is levigation. Levigation is also using in a small scale preparation, mostly for ointments and suspension. Also, most of the time, levigation can be used in mortar pestle or can be used in using a ointment slab or ointment pad. Pulverization by intervention. For these methods, generally a solvent will be added to some kinds of coarse powder to dissolve the powder, and then the solvent here should be volatile. Doesn't mean it can be evaporated easily. After dissolving into solution, then the solution will be evaporated, and after evaporation it will form a fine powders. For example, camphor is a crystalline form, It's very difficult to gyrate or grind or mix with other powder using the gyrtation method or levitation method. In order to create fine powders of camphor, crystalline can be added with alcohol. Alcohol is a volatile drug. It can be evaporated easily. After adding alcohol, alcohol will dissolve camphor crystalline into solution. And after solution is formed, it can be evaporated. And when after evaporating, the solution will form a fine powders of camphor. And when a fine powders of camphor is formed, you can use this one and gyrate or mix easily with other ingredients. These are the two videos for gyration and levitation. It's very helpful for you to watch and to see the techniques in practice. It's important to know that the particle size of the powder need to be reduced to the desired size. For each powder need to be in the desired size before being weighed or blended. So if you have many ingredients, you need to check the size. And if like the size is large, you need to reduce the size separately before you add them together. In general, powders can be blended or mixed by manual method or mechanical method. Mechanical methods of using different type of mixer or blender normally is applied in industry or in the pilot scale of the laboratory. In compounding pharmacy, manual methods is usually applied to mix or blend the powder together. Spatulation methods can be done using the ointment tile or ointment slab and spatulas. Small quantity of powder or other ingredient can be mixed together, and there is only mixing, no size reduction in spatulation. Gyrtation. The particle of the powders can mix together in a mortar pestle using gyrtation. These gyrtation methods can mix them together and also help to further reduce the size of particle. Geometric dilution. Geometric dilution can be applied on ointment tile or in mortar pestle. It's applied usually when mixing a small quantity of drug with a large amount of excipient. In the geometric dilution, usually small amount of the drug and small amount or equal amount of excipient is mixed together first, and then a similar amount of the mixture from the excipient will mix together and add on until all the excipient or the powders is being used. Please watch this video for further definition and description of geometric dilution. Before blending or mixing powders, it's important to know some special properties of certain kinds of powders. There's some powders have some special property like eutectic, hygroscopic, and deliquescent or efflorescent. So the properties is very special, and it's important to know it before mixing them together to avoid any instability. Also, incorporation of powders into liquid or liquid into powder is very important to know and design to avoid any wrong or failed formulation or to avoid any instability. What's a eutectic? A eutectic mixture occurs to some powders when the powders in solid. When adding together with the equal amount, the mixture will turn into the liquid. So for this kind of eutectic mixture, it's important to avoid the liquefy before mixing, or sometimes you can use the liquefy as a design mixing. If you want the eutectic mixture, that means you want a liquid or liquefied preparation after you mix two eutectic mixture powder together. If you desire this, then first you need to mix them together. You mix the two ingredients together to form the mixture, a liquefy. And then after you have the mixture, you can add all the ingredients or can be adsorbent or some other ingredient, excipient, or other base. In case you don't want to form eutectic mixture, or eutectic mixture is not desired, so to avoid the eutectic mixture, each ingredient needs to be, or each kind of powder needs to mix individual with other ingredient or other inert substance, and then you can mix them together. In this case, there are very low possibility or no chance of contact of equal amount. Eutectic mixture won't be formed, and the final preparation will be still in the dry powder. There's many kinds of ingredients can be eutectic mixture when you mix them together. For example, benzocaine, camphor, menthol, lidocaine, salicylic acid, etc. If you mix menthol and camphor in a similar amount or similar quantity, when you mix them well together, menthol and camphor in the crystalline form, when you mix them together, the mixture will turn into liquefied or liquid. And this is a eutectic mixture of menthol and camphor. The next special property of a certain powder is a hygroscopic and deliquescent property. For this kind of powder, the drug or chemical has this property, can absorb moisture from the air and become liquefied. To protect the powder from to protect the hygroscopic and deliquescent powder, the powder need to be dispensed in the tight containers. Or in the compounding, the hygroscopic and deliquescent powders will be diluted with an inert dried powder first, and then this mixture will be mixed with other ingredients. So this will reduce the amount of surface area exposed to the moisture and avoid any liquefied preparation form. Example, calcium chloride, ephedrine sulfate, or phenobarbital sodium, etc. These powders very sensitive to moisture, and it can draw the moisture and become qualified. So again, for these kinds of powder, this need to be dispensed in a tight containers. Another types of special powders are efflorescent powders. Efflorescent powders are crystalline powders that contain water of hydration or crystallization. So for this kind of powder, the water can be liberated either during the manipulation or on exposure to low humidity environment. The powder becomes sticky and pastry or even liquefied. To avoid liquefied formation from efflorescent powders, it's recommended to use anhydrous salt form of drugs. Avoid using hydrated products, including a drying bulky powder, and use a light, non-compacting method of mixing the powder. Example for some kinds of powder drugs that has the property of efflorescent powders, they are atropine sulfate, caffeine, citric acid, cocaine. When you mix powders, mostly that's just simple mixing, and if like you incorporate small amount to large amount, you use a geometric dilution. To incorporate powder to liquid, there's some consideration to avoid any instability. The liquid, in case the liquid add into powders, the liquid will be let the liquid absorb onto inert material, for example lactose or starch first. The liquid, when mixed with this kinds of inert material, it will be absorbed, and then will be less liquefied, and then this mixture will be added into the bulk powder using the geometric dilution. If you add pasty and powders, the pasty material will be added to dry powder first by mixing it with increasing quantity of powder, which is dry out of the paste. Powders can be ingredients for further formulation of tablets, capsules, suspension, or solution, or powders can be a medicine itself. There's many kinds of medicated powders: topical powders, insufflated powders, aerosol powders, bulk powders, and divided powders. Powders can be ingredients for further formulation of tablets, capsules, suspension, or solution, or powders can be a medicine itself. There's many kinds of medicated powders: topical powders, insufflated powders, aerosol powders, bulk powders, and divided powders. When powders is used as a medicine in topical powders, it's important to have the particle size is uniform and small, because this property will help avoid any irritation to the skin when applied to the skin. The powders must be impalpable, free-flowing, and easily spread on the skin. Also, the powder needs to be adhered to the skin for good contact. In case the topical powders are used for oozing wound, avoid using any salty powder because this can create hard crust. Using more hydrophobic, water repellent powder. This will help to prevent the loss of water from the skin and will not create any cake on the oozing surface. Example, using talc is a kind of absorbent. And if the powder is used for oozing wound, the powder needs to be sterilized to avoid any infection in the area. There are some examples of topical powders. For example, wound seal powder. This is a mixture of hydrophilic polymer and potassium ferrate. This helps to treat the minor external bleeding. The powder will be applied directly on the surface of the injury or the wound. Z-Absorb super absorbent. This is an antifungal drug. It contains miconazole nitrate and some other excipients like tau, cellulose, sodium. Another one is a gold bond body powder. The gold bond body powder includes menthol and zinc oxide and some excipients like tau, eucalyptus. This helps for temporarily relieve pain and itching associated with minor cuts and scrapes. And this powder is applied directly on the skin. Another dosage forms of powders are insufflated powders. Insufflated powders are finely divided powders intended to be applied in the body cavity, such as ears, nose, vagina, toe socket, or throat. Mainly for this kind of powder, it contains an ingredient for the anti-infectiveness. To administer any insufflation, the powder is placed into the insufflator, and when the bulb is squeezed, the air current carries the fine particles through the nozzle to the region for which the medication is intended. Pressurized package provide an elegant approach to the administration of insufflation. This video from the link here will show you clearly the method how to administer an insufflation product. Another application for medicated powders is aerosol powders. Some medicated powders are administered by inhalation with the aid of dry powder inhalers or DPIs. DPI is a dry powder inhalers. The DPIs can deliver micronized particles of medications in smaller quantities. In general, the DPIs is composed of a mixture of active pharmaceutical ingredients or drug and excipients. The excipients can be inert propellants and some other excipients like crystalline, alpha-lactose, monohydrate, etc. This is an example of DPIs. Mostly the DPIs containing aerosol powders used for the treatment of asthma and other bronchial disorders that require distribution of medication deep in the lungs. The particle size is important for aerosol powders when it is designed to deliver into what side of the lung. Look at the diagram here. You will see if like more than 10 microliter, the aerosol powders can be delivered into this side. The smaller size of the particle, the deeper the powder can be delivered using the DPIs. In general, particle size of micronized medication for aerosol powder is in the range of 1 to 6 micrometer in diameter. So 1 to 6 micrometers, so the powder can be delivered to this region of the lung. And these are some examples of oral inhalation powders from the aerosol powders using through the oral administration. The first one is the Advair Discus. This one contains fluticasone propionate at the dose of 100, 250, or 500 milligram, along with salmeterol 50 milligram in a powder for inhalation. This is an example of the 100 milligram of fluticasone and 50 milligram of salmeterol. This product is used for chronic obstructive pulmonary disease or COPD. In the disc here of the product is contain many blisters, and each blister contains one complete dose of medication. The blister is open by activating the device, and medication is dispersed into the airstream created by the patient inhaling through the mouthpiece. This is a picture of administer of the Advair Discus. The administration method or instruct the patient how to use the Advair Discus can be found from the link here. The link here will lead you to the video of the methods how to administer the product. Another example is a 4-gel aerolizer. These ones include the capsule for the oral inhalation, and the capsule will be put to use in the aerolizer inhaler. This product also for controlling symptoms of COPD or chronic obstructive pulmonary disease. The capsule here contains dry powder formulation of formoterol, fumarate, and lactose. The active API is a formoterol fumarate, and the lactose is an excipient. How to use it? The capsule will be taken out and placed inside the well of aerolizer inhaler, and the capsule is pierced by pressing and releasing the buttons on the side of the device. The patient inhales rapidly and deeply through the mouthpiece, depositing formoterol fumarate formulation into the air of inhalation. This link here will lead you to the video of instruction how to use a 4-gel aerolizer product. Another example for oral inhalation powder is a Relenza. It's containing zanamivir for influenza. This one is packed in the rota dish and administered using a inhaler. It's pretty similar to Advair Discus. The link here will lead you to the video of instruction how to use the product. Another application of powders is in the medicated bulk powders. Bulk powders are available in prepackaged amounts. This is an example of the bulk powder in the bottles. Each bottle contains many doses, so the patient need to take it out small amount at a time based on the dose recommendation. Example for bulk powders can be antacids. Example, this product contains sodium bicarbonate, laxatives. For example, this contains the polyethylene glycol. Douche powder examples are Massageal powder for vaginal use. Medicated powders for external application to the skin, for example, paxitracin, zinc, and polymyxin B-sulfate for anti-infectiveness. Pru's yeast powder containing B-complex vitamins and other nutritional system. Disadvantage of bulk powder is inappropriate for potent drugs. Because the using of dosing can be inaccurate by the patient. So potent drug shouldn't be used in the bulk powder. Potent drug is the drugs used in a small amount and can have therapeutic effects. So any inaccurate dosing can lead to ineffectiveness or toxicity. The bulk powder has advantage like it can be in dispensable quantity and the cost can be like cheaper. Some bulk powders can be taken out and mixed with water for oral use. For the patient using the bulk powders, it's important to educate the patient on appropriate handling, storage, measurement, and preparation. Remember, the measurement is using the scoop or some kinds of device, and it will be made by the patient. So it's important to educate the patient how to measure it appropriately or accurately, so that will ensure an accurate dose. The handling and storage is important because there's many dose remaining. If the storage or handling is not appropriate, the remaining products can be degraded and have no effectiveness. Normally, bulk powder is stored in the room temperature in a clean and dry place. Another application for medicated powder is divided powders. After a powder has been properly blended, it may be divided into individual dosing units based on the amount to be taken or used at a single time. For example, divided powders are headache powders. Some kinds of powders in the small package like this individual package, and the powder inside can be mixed with water for oral administration later. Or the powder laxative. The powder laxative is also in the small units and will be mixed with water before use. Douche powders is a kind of douche powder using mostly for vaginal use. Each divided portion of powder may be placed on a small piece of paper. In case the paper is used, the line work called charge in abbreviation charge, or it can be in powder paper. The paper is folded to enclose the medication. The kinds of divided powders can be available on manufacturing products or compounded preparation. In compounding, the powder usually used manually folded with the paper. If the hygroscopic or volatile powders, the glassite weighing paper or wax paper should be used to avoid any loss of water. For other normal powders, parchment paper, powder papers made of vegetable can be used. Okay, so we just learned about powders, property, and their application. Another case of dosage forms or particles very close to powders are granules. Granules are prepared agglomerates of smaller particles of powder. That means granule is an aggregation of many kinds of particle powder. So particle size of granule is much bigger than powder. Usually it's in the 4 to 12 safe size range. In the big large size like this, the flow property of granules is better than the powder. Usually the granule is commonly used in tablet making. That means granules will be continued to use for compression into the tablet. Due to the large size like this, the surface area is smaller than the powder. Because the surface area is smaller, so is there less chance to exposure to environment like moisture or air. So the granules is more stable to atmospheric humidity than powder. The granules is agglomerates of powder, but it's in the dry form. Usually it's easier to be wetted than the powder. So for the product intended to be constituted into solution or suspension, granules is preferred than the powder. In case the granule is used as a medicated product, usually the granules will be reconstituted with suitable liquid before being dispensed. For example, for antibiotic drugs or lactinase granules or effervescent conduits, usually the granules will be mixed with water or certain drink or suitable liquid, and then the liquid will be administered orally. A very special type of granules is effervescent granules. These are kinds of medicated granules. Effervescent granules usually provide pleasant vehicle for bitter or salty tasted drugs. Even though it's in liquid, but it can mask the taste or the flavor of the drugs. In the effervescent granules, usually it composes of sodium bicarbonate, citric acid, and tartaric acid. The granules will be added to water. Based on the reaction of the acid and the sodium bicarbonate in the water, they will release some carbonated solution or carbon dioxide in water. And the carbonated solution have to mask the undesirable taste of the drug. Granules can be made by different methods: a wet method, dry method, or fusion method. The wet method is the most common method used in compounding. The powder will be moistened with certain solvent, appropriate solvent, to make a paste. Then the paste will be passed through the screen of mesh size, and the size is depends on the purpose of the use. It can be from 4 to 12 size range. Finally, this will make some kinds of granule, and the granules will be dry to form some dry granule. And these granules can be medicated granules used mixed into solvent or liquid for use, or the granules can be continue being compressed to make the tablets. So we just finished the lecture. This is the summary for the lecture. First, pharmaceutical powders are intimate mixtures of dry, finely divided drugs and or chemicals that may be intended for internal or external use for local or systemic effect. Pharmaceutical powders must have appropriate properties for purpose of use. Powder particle sizes can influence the stability and effectiveness of medicated powders. Particle sizes of powders can be decreased using levitation, titration, or pulverization with intervention methods. Powders can be mixed by spatulation, titration, levitation, and geometric dilution methods. Special consideration of powders are for eutectic powders, hygroscopic and deliquescent powders, efflorescent powders, and the method to incorporate powders with liquids. Powders can be in a dosage form for topical powders, insufflated powders, aerosol powders, bulk powders, or divided powders. Granules are prepared agglomerates of smaller particles of powder. The size is in the range of 4 to 12 safe. Granules have the size much bigger than powders. Granules can be a part for other dosage forms, for example, tablet capsule, or constituted with a suitable liquid prior to dispensing. Granules can be prepared using wet, dry, or effusion method. Effervescent granules are usually composed of sodium bicarbonate, citric acid, and tartaric acid. After dissolved in water, effervescent granules produce carbonated solution, which helps to mask the bitter or salty taste of the drug. Okay, so we just finished the lecture. If you have any question, please come to my office hours or email me. Thank you for your attention.